right? So before we go to the next property, so let me uh, write down what happens if the Fourier transform. Okay, I want to find the Fourier transform of just cos omega naught t and sin omega naught t. Okay, so that I will write down. Finding CTFT for cos omega naught t and sin omega naught t. Okay, so let us try to find out. Let us start from first principles. Okay, what do I mean by that? So we know that, what do we know? We know that one will have what as Fourier transform, will have, let me call one to be x of t. Okay, let's say x of t equal to 1 will have x of j omega, which is equal to 2 pi times delta of omega as the Fourier transform. This we have seen, right? I gave you 10 examples. In that 10 example, this is one of the signal. If I am not wrong, it should be some 6th or 7th signal. Okay, so now let us define a new signal to be x1 of t, which is equal to e power j omega naught t. So what is this fellow's Fourier transform, right? So note that e power j omega naught t can be written as e power j omega naught t into 1. So is it not looking like e power j omega naught t into x of t? Why? Why? Because 1 we assume it to be x of t. So this fellow will have what as Fourier transform? x1 of j omega, which is equal to how much here? X of j omega minus omega naught. This would be equal to 2 pi times delta of omega minus omega naught. Okay, so we got Fourier transform of e power j omega naught to be how much? 2 pi times delta of omega minus omega naught. Okay, so just for plotting purpose, so e power j omega naught is a complex function, so we cannot plot in time domain. But what happens to the signal in frequency domain? That is 2 pi times delta of omega minus omega naught. Means what? Shift Dirac delta function to the right by how many units? Omega naught units. So this would be the Fourier transform of which signal? E power j omega naught t. And what is strength of that signal? It is strength of that Dirac delta function, that is 2 pi. Okay, right. Similarly, what can you say about e power minus j omega naught t? So proving in a similar fashion, you get e power minus j omega naught t to have what as Fourier transform? 2 pi times delta of omega plus omega naught. Okay, right. 2 pi times delta of omega plus omega naught. And how does the plot look here? The corresponding Fourier transform. Okay, I'll draw like this here. Yes, what is that you have to do? You have to shift the Dirac delta function to the left by omega naught unit. So you will get minus omega naught with strength 2 pi. That is the Fourier transform of which signal? E power minus j omega naught. Now what will I do? We will add these two fellows. So this implies, correct, e power j omega naught t plus e power minus j omega naught t will have what as Fourier transform? What property we are using? We are using linearity property. So first fellow will have 2 pi times delta of omega minus omega naught, plus second fellow will have 2 pi times delta of omega plus omega naught as the Fourier transform. Okay, so but what is the left hand side? That is nothing but 2 cos omega naught t. So that fellow will have 2 pi is common. We will have delta of omega plus omega naught plus delta of omega minus omega. I just reordered the Dirac deltas, but 2 is common for both sides, so you will get 2 cancelled. And finally, what is that you get? You get cos omega naught t will have delta of omega plus omega naught plus delta of omega minus omega naught as the Fourier transform. And what is strength of each Dirac delta? that is pi. Okay, now let us try to plot this function. Okay, note that this is in frequency domain. So what do we have? We have two Dirac deltas. Okay, and where are they located? They are located at minus omega naught and plus omega naught, and each with strength how much? Pi. So that would be the Fourier transform of which signal? Cos omega naught t. Now let us subtract. Okay, so we will, what happens if we subtract? So if you subtract, we get e power j omega naught t minus e power minus j omega naught t. So this fellow will have 2 pi times delta of omega minus omega naught, sorry, minus 2 pi times delta of omega plus omega naught as the Fourier transform. But we already know that e power j omega naught t minus e power minus j omega naught t is how much? 2j sine omega naught t. Will have what as Fourier transform? 2 pi times delta of omega minus omega naught minus delta of omega plus omega naught. So 2 is common, we can cancel it out. So you multiply throughout with j, so or minus j, correct? So if you multiplying throughout with minus j, what will happen here? You will get sine omega naught t. So this implies sine omega naught t will have what as Fourier transform? Pi multiplied with j, because you multiplied throughout with minus j. I take minus inside. So what will happen here? You will get delta of omega plus omega naught minus delta of omega minus omega naught as the Fourier transform. Okay, right. So let us try to plot this. I remind you again, because the function is complex, it is not right to plot it, but according to engineering, that's okay. As far as engineering is concerned, that's okay for us. Okay, yes. So what happens? You have Dirac delta at minus omega naught, and that fellow strength is how much? Pi j. And again you have a Dirac delta at plus omega naught, and that fellow strength is how much here? Minus pi j. So that would be the Fourier transform of sine omega naught t. Okay, so just for understanding, we will take few examples. Okay, yes. So we'll try to, no, this is just example. Okay, what is the Fourier transform of cos 1000 pi t? Okay, I'll write down find CTFT of. Okay, so first signal cos 1000 pi t. So definitely this fellow will have pi times delta of omega plus 1000 pi. Why? Omega naught is 1000 pi plus delta of omega minus 1000 pi. So definitely, how does the plot look? You have two Dirac delta functions at where? At minus 1000 pi, and another fellow at plus 1000 pi. And what is strength of each Dirac delta? That is pi. So this would be the Fourier transform of cos 1000 pi t. So as another example, we'll find the Fourier transform of, let us say, sine 100 t. Okay, so what will be this fellow's Fourier transform? Just now we have seen it is pi j multiplied with delta of omega plus omega naught, which is 100, minus delta of omega minus omega naught, which is again 100. So if you plot this, how does the plot look? The plot looks like this, correct? So you have a Dirac delta at minus 100 with strength pi j, and similarly you have another Dirac delta at 100 with strength minus pi j. So this would be the Fourier transform of sine 100 pi t. So in that way, either for cos omega naught t or sine omega naught t, what will happen? The Fourier transform will have only Dirac delta function. So is that justified? Yes. Why? Cos omega naught t will have only one frequency. What is that? Omega naught. So it can be either plus omega naught or minus omega naught. Why? You can rotate either in clockwise direction or anti-clockwise direction. So negative frequencies corresponds to anti-clockwise rotation, and positive frequencies corresponds to clockwise rotation. Okay, and that's the reason why you have two impulses at plus or minus omega naught. Okay.